Yes, good evening to all. I welcome all the participants for today's faculty lecture series. Today's resource person is Sri MD Mahbub Pasha sir, Assistant Professor from ECE Department. So I welcome to Mahbub Pasha sir, today's resource person. Sir, I request you to please start the session, sir.
Okay, thank you, sir. Thank you very much. Welcome all the participants. Very good evening, and respected Dean CRI Venkatnarayana sir, all the senior faculty members and colleagues and students. Good evening to you all. So today I am selected. I have selected a topic called infrared non-destructive testing. So here I am going to generalize this topic, not constraining to a particular branch. So I am generalizing the topic, and I am also not going much deeper into the mathematical analysis of that. A overview type of topic I have taken, generalized way I am going to explain you. So what is this infrared non-destructive testing? So first of all, what is non-destructive testing? So non-destructive testing is an application. That means here we will try to assess the quality of a material or an object or a surface without damaging that material. So without damaging the usefulness of the material, we will assess the quality of the material. So that method is called as non-destructive testing. So in the name itself, it is a non-destructive. So it will not destruct or disturb the actual properties of the material, as well as it will assess the quality of the material. So in this, there are different types of non-destructive testing methodologies are available. So like ultrasonic testing, eddy current testing, radiographic testing, like that different methods are there to test a material or object or surface in various ways. Particularly here, one I am concentrating on infrared thermography. Okay, a particular area of non-destructive testing I am trying to explore here is infrared non-destructive testing. So, what is infrared non-destructive testing? And before going to infrared non-destructive testing, why we require non-destructive testing, where we face non-destructive testing? So generally in various applications, say it may be aerospace, automobile or mechanical industries, electronics, semiconductor industries, electrical installations, wherever we go, when you are deploying a material, deploying an equipment, the equipment must be of good quality. Then only life of the material, life of the equipment will be high. Otherwise, if the quality of the material used to manufacture a particular equipment is not good, not well, then the overall life and overall rating of the material, overall of the equipment will be degraded. So the utmost care must be taken before actually using a particular material for manufacturing or for any purpose, in any applications. So this that is the need for non-destructive testing. So without actually damaging the material, we need to test how well the material is, how well the material is suitable for a particular application. So that is where non-destructive testing comes into picture. But even though when during, so why these defects are present, that means while manufacturing there may be different types of defects present, even though utmost care may be taken while manufacturing a material or whatever it may be. So there are different types of defects such as voids, delaminations, air bubbles may be trapped into the material, cracks may be there. So in sensitive applications like aerospace applications, that is manufacturing aeroplane body and satellite panels or any other sensitive materials, require very utmost, very good quality material should be used for manufacturing this. So there we need a non-destructive testings. We have to test the quality of the material before actually deploying. So there this non-destructive testing comes into picture. So here the different types of these defects or anomalies or disturbances may be in different manners. As I mentioned, it may be voids, cracks may be there, delaminations will be there, air bubbles may be present, or when the painting defects may be present. So different types of defects may be present available in the material. So before actual deployment, we need to test the material. So here, the most widely used non-destructive testing method is the infrared thermography. So what is this infrared thermography? So it is a field, it is a method in which it is a whole field non-contact method. So it is a whole field non-contact method to assess the surface or subsurface information of some area, some surfaces or some materials. Quickly we can assess the quality of the material using the temperature evaluation over the objects. That is, in the infrared area, the method used to assess the parameter which we use to assess the infrared images is temperature. So using the temperature over the object, when you capture a image, infrared image of an object or material or person, whatever it may be, it captures the thermal radiation. That is how much temperature is there. So based on that, we will get an image. So based on different colors, that is based on the degree of the temperature, color will vary. So based on the color variations, based on the contrast of the image, we can assess the quality of the material. We will take the image of a good material, and we will compare it with the defective material. So when we compare, if there is a contrast is there, color variations is there, we can know there is some disturbance is available. So particularly this infrared thermography, it relies on thermal inhomogeneities in the test object. That is, if at all any defect is present, there is some difference in temperature over that object. So there this infrared thermography is used. So infrared thermography, it is a non-contact method of assessing the quality of the metal using the temperature evaluation over the object. So this is done using an infrared camera, a particular camera which captures infrared radiation. Okay, so there that cameras are useful here. So infrared is the band. So here if you see, infrared is the band. After visible band, we will get infrared, then microwaves, radio waves, like that. If you go towards right side or towards the, as we decrease the wavelength range, then after that visible length, we will get visible wavelengths we will get, then ultraviolet, X-rays, like that. So here infrared radiation, particularly here the measure is temperature. In the infrared range, the measure which we use is temperature variations. Whereas if you take X-rays, X-rays is intensity variations. That is, if the body is opaque, the intensity will be different. If the object is not opaque, intensity will be different. So here the intensities varies based on in the X-rays based on the opaque or not opaque. So here in the case of infrared, the temperature variations are observed. So when you capture an infrared image using an infrared camera, based on the surface temperatures or body temperature, different colors are there. So each color is assigned one temperature value. So here particularly in the infrared range, we use temperature as the parameter. So based on that, we can know the image. Okay, so in this infrared thermography, so the methodology to test the objects or materials using this infrared thermography is, first, using an infrared camera, we will capture the surface radiation of the object. That is, surface radiation is emitted from the any object, any subhuman body. If you take some surface temperature will be there, so it will capture that surface temperature. This surface temperature or infrared energy, that will be converted into temperature map, and that temperature map will be displayed as images. So here a particular camera like infrared camera captures this radiation and converts into temperature images, and a sequence of images are taken. Using that sequence of images, we can assess the images for the temperature variations. Okay, so this is how infrared thermography works. So here a object radiation is captured using a particular camera called as infrared camera, and using that images generated, sequence of images generated using that camera, we can assess the images. So it may have various applications, different applications this infrared images have. So here, particularly in this infrared thermography or infrared non-destructive testing, These is classified into basically two methods, two types, basically broadly classified into two methods. So in this one, first one is passive thermography. So in the case of passive thermography, it will capture the natural temperature without any externally we will not provide any heating or anything else. Directly it will capture the surface temperature of the object or material, whatever it may be, using an IR camera. So naturally, whatever natural temperature or natural radiation occurs over the object, the surface of the object will capture it. So based on the temperature levels, different colors will be assigned. So based on the temperature, color will vary. So based on that, we can assess the image. So this type of passive thermography has many applications, like in the agriculture and biology. In the agriculture field, to know any bacteria or germs or virus is present on the outer surface of the some crops, that can be assessed using this infrared camera. Or in medicine, so due to fluorescence nature of the various atoms or various particular things, we can use this infrared thermography, like and building thermal efficiency survey. So that is how much well, that is in a building survey, so whether there are any cracks on the building or not. So to assess the quality, there we can use. And radio traffic, road traffic monitoring, and detection of gases. Whenever there is a gas leak is there, their temperature will be different, so based on the gas. So like that, this can be used, so without any external stimulation. So directly, whatever natural or in the ambient conditions, whatever temperature is present, that can be accessed using this in this method of thermography, passive thermography. So here, even though it is very simple in nature, the problem here is it can only capture the surface temperatures. If whatever surface temperatures are there, so it can capture. But if a defect or crack or whatever it present inside the material, so this type of material may not exploit that defect. The material defect present inside the material, it may not assess. So that is the main drawback of this material, of this method, passive thermography. So if any defect lies inside, so it is not possible to assess using that method. So to overcome this, there is another second type of method called as active thermography. Okay, so in this active thermography approach, so externally we will supply a stimulation, that is heat. We will heat from the externally, we will provide some heating using some lamps, halogen lamps, or some optical heating. So using light sources, heavy light sources, we will heat the object which you want to test. So after heating, that will radiate. So that radiation is captured using the IR camera. So this is the schematic here. This schematic here shows this one. So this is IR camera. So this IR camera will capture the radiation from the object. So these are the external heat sources which project onto the object, and the radiation is captured here. So the principle here is the externally whatever stimulations, external optical stimulations we are giving, so it will cause the internal flow of the heat. That heat will propagate inside the material. So this has certain rate, that propagating heat inside the material will propagate with certain rate, flow rate. Okay, that is called as the diffusion rate. So whenever, suppose if at all any defect is present, that the diffusion rate will get altered there. The diffusion rate will change at that point. Due to change, that then there will be a thermal gradient, that is temperature over that point will also change. So that reflected waves that are coming from the object after it is radiated using optical external sources, that will be captured using an infrared camera. So the point where defect is present, that is the reflected waves from the point where defect is present, and the reflected waves from the point where no defect is present, there will be a difference in temperature. So this variation in temperature can be visibly observed using infrared camera images. That is, whatever infrared images, sequence of images we will get, in that sequence of images, we can by visibly by our eyes we can see that temperature variations, and we can know if at all any change is there, we can know that at this point there is a defect. Okay, so here in the right side, so here an object is placed. So here this is an object. So this is radiated using this method. So after capturing the images and after doing some processing, this is the one of the frame in this sequence of images captured by the infrared camera is like this. That means wherever there is a different in color, that means there is some defects. That is, in this method, in this material particularly, some intentionally some defects are made to make you visible, like for doing the experimentation purpose. So that is captured, and we can see these are the defects present, and using the diameters of that, and we can know the how much width is that, how much depth is that, based on various other parameters. Okay, this is the basic principle of this the active thermography method. So here a source, the optical source is used to illuminate this object which you want to test. After that, these waves flows into the material and they get reflected back. The reflected waves are captured by the IR camera. So these reflected wave, due to the presence of defect, due different surface temperature map. That is, on the surface, different temperature map it will give. So based on that, you will get the output. So what is the advantage of this method? Why this method is advantage? In this method, characteristic of the external thermal stimulation is the light source we are using.
Sir,
In what manner?
voice is little bit flickering, sir. Sound. The voice is.
Just a minute, sir.
Yeah, yeah.
Now is it okay, sir?
Okay, sir. Yeah.
Okay. So here, in this, why this active thermography is so popular. Here, the heat sources or optical source which we are using to illuminate the object, its characteristics are known to us. That is, in what manner you want to apply the heat stimulus or external optical stimulation is known. That is nature of excitation. That means what is the shape of the waveform you are using to excite. Then time duration, how much time you are illuminating it, and what are the frequencies, in what manner you are varying the optical source is known to us. Since it is known, the reflected waves captures the, using the reflected waves we can assess the various quantitative or qualitative characterization. Qualitative characterization means how much depth the defect is there, how much width the defect is there, what is the area of the defect. So that can be assessed. That can be assessed using this method of, that is, active thermography method. Even though this method has some various popular, there are some shortcomings. That means the optical waves, that is thermal waves which are propagating into the material, they are highly attenuated by the this object, that materials. So due to this, what we require high energy optical stimulation is required. And also, when you are using a high energy optical stimulation, there are certain type of noise present, that like non-uniform radiation, flickering noise, or so the different type of noise due to camera sensors. Likewise, different noise may be present. So these has to be processed. So that is the requirement. So during this past few years, lots of research is done on what type of stimulation we should give and what should be the processing method to extract the defects using this method. So particularly in these three types of stimulations are most widely used. One is pulse type of stimulation. In the pulse type of stimulation, the light source is switched on with a constant magnitude intensity, and after some duration it is switched off. So this is like a pulsed. And in another one, sinusoidal way, that is optical stimulate, light is varied in a sinusoidal way. That is the optical stimulation, that light source is intensity is varied using in the sinusoidal manner. And another type of recently introduced is chirp type of stimulation. That means the stimulation is varied in the form of chirp. Whereas in the case of sinusoidal, only one frequency component is induced into the material. Whereas using the chirp, different band of frequency components are induced into the material. The advantage here is using the chirp when compared to sinusoidal is, in the sinusoidal, when you induce the light using the, induce the signal using optical source in this manner, sinusoidal manner, there is a one component called parameter called as diffusion length. That is how, how the light rays goes into the material. So here it has only one diffusion length. That means the signal can only track the defects present at only a particular depth only, up to one particular depth only. So different frequencies components can extract defects at different depths. So in this manner, chirp signal has certain advantages over sinusoidal excitation methods. Recently, this chirp has been introduced. So coming to the overall generalized method, how to apply this active thermography is, first we will have to, based on the application, we will choose a suitable stimulation method. That is how the light source should be varied, either in a pulse manner or sinusoidal manner or chirp manner we will select. Then this light source is projected onto the surface, and after that, using a camera, we will capture the response, temperature response from the object. Then we will get a sequence of images. So after we get a sequence of images, we will do pre-processing to remove any noise present, non-uniform radiations, unnecessary radiations are present. So to remove that one, pre-processing is done, and also to extract dynamic response from the recovered thermal response. So for that purpose, pre-processing is done. And then we go for actual post processing. That is actual. This is the method for actually assessing the defects inside the material. Likewise, various methods may be method like sharpening sharpening the images. Likewise, different methods can be applied here based on our need. So here, so briefly, this is the same thing which I have explained here. So same schematic is presented here. So here, using external stimulation, we will impose the optical light onto the object, and then it will capture the using a IR camera. Then we will get a sequence of images. So in the pre-processing stage, so suppose this is the stimulation and the top figure, top left graph. If this is the stimulation signal, if you are giving, so then here, if you give the exactly the around the zero setting, that is DC is no DC setting is there, DC is 0. So around the DC value, if you give the vary the intensity of the light, so when you go above DC, it may be treated as heating. When you go below DC, it may be treated as cooling. Since a light source cannot be heated and cooled simultaneously at a time, so what we will do is we will add some DC levels. That is some fixed intensity we will keep first. Then we will vary the intensity of the light. So we will add some DC. So when you add some DC and we explore, that is induce onto the object, and again when you capture using a camera, we need to remove this DC. So we need only the dynamic portion, how the intensity is varying after it is reflected back. That is what we want. So then, using some curve fitting or polynomial fitting or any other method, we will remove the DC, mean removal. That is nothing but DC is removed here, and only dynamic portion is captured. So here, why the waveform is in this manner, in single manner, means suppose we will get a sequence of images. Okay, here we get a sequence of images. For example, here we get a sequence of images like this. In this manner, we are getting the sequence of images. So here, if you take a particular pixel location, so suppose there are 2500 frames are here. So for example, if you take a particular pixel location, and we will take all the intensity values and same pixel location for all the 2500 frames, then we will get one signal with 2500 samples. So that is this signal. So that is this signal. Okay, that is this signal, whatever we are getting, that is this signal. So individually at a pixel location we will take, then this signal will become a 1D signal. Then we will process this 1D signal. After processing, we will at the same location we will relocate the this processed image. So after doing this pre-processing step, the post-processing step is done on this waveform. Then after doing the post-processing, like a 50 phase method, pulse compression, principal component analysis, different methods we will use to extract the defect information. So after extracting, after doing that processing at the same pixel location, we will place that waveform. So in that manner, the post-processing, pre-processing and post-processing will be done in this active thermography approach. So using that post-processing, we can extract the image defects present in the object. So these are the generalized, again, in generalized way I am giving here block diagrams. First, that we will get the sequence of images. Then we will do the pre-processing. Then that is we extract the dynamic portion, and then we go for post-processing. Different transformations, different methods we will apply. Then we will estimate the contrast level. That is based on the image, we will extract the contrast level. Based on that, we will say where the defect is present, where the defect is not present. Again, we will get a 3D view. Okay, so these are the different conventional methods of thermal wave imaging. So based on the type of stimulation, one is pulse thermography. So in this pulse thermography approach, so a pulse type of stimulation is given. Then using the IR camera, we will capture the thermal response, and we will take only the magnitude portion. Using the magnitude, we will plot the images, and we will search for the image where contrast image is obtained, where we can find the defects. So in that, the drawbacks of these methods are it requires high peak powers. That is a main drawback. High peak powers it will require. So due to that, sometimes the material may be damaged, and some non-uniform radiation effects are more in this method. So in the similarly, a little bit extension of pulse method is pulse phase thermography. In this, the whatever response we will get, thermal response to at each pixel location, we will apply the Fourier transform, fast Fourier transform, and we will get magnitude and phase part. We will extract phase part. Phase is not less sensitive to noise, so we will extract phase part, and from the phase images we will assess the images. So that is using FFT phase. Another method is lock-in thermography. That is, here we will use sinusoidal stimulation, sinusoidal type of stimulation. We will extract, again same method is followed. We will extract the thermal response and apply the fast Fourier transform, and then we will take the phase images. Here the advantage of this lock-in thermography is we can apply less power sources. We can use less power sources. We can use, but the problem here is, since it is having only one frequency component, it can detect defect at only a particular depth. If you want to detect the defects present at all the locations, we need to repeat the experimentation with a different frequency. So that is the problem with this method. But the advantage here is it can use less peak power sources. That is the advantage here. Whereas recently introduced some stimulation techniques are linear frequency modulator. That is chirp side type of stimulation we will use. So the advantage here is a band of frequencies are induced into the material. So due to the introduction of a band of frequencies, the advantage here is the defects present lying at various depths can be extracted using a single experimentation. So the extracted images, whatever we get, we will again post-process using various techniques, and we can identify the defects present in that. So and here the extension of this linear frequency modulation is quadratic frequency modulation type of stimulation is used recently. So in this, the advantage here is, what is the advantage of this quadratic frequency modulation is, generally the waves which are propagating inside the material. So lower frequency waves will propagate more deeper than the higher frequency waves. That is, if you want to extract a defect lying at very deeper, we need to give lower frequencies. So low frequency requires more energy, large frequency requires less energy. So this quadratic frequency modulation, if you plot the frequency spectrum of this, lower frequency has more energy, higher frequency has less energy. So due to that, lower frequencies can penetrate more deeper, and it is possible to extract the defects present at deeper length. So that is the advantage of this quadratic frequency modulation technique. So these are the post-processing which we can, some of the post-processing methods which we can apply onto the material. Just before, as I mentioned, fast Fourier transform method. So in this, at each pixel location, we will extract the total all the pixels in the frame. Then we will do Fourier transform. We extract the phase, and again whatever phase value you get, replace at the same locations. Likewise, we will do for all the pixel locations, and we will extract the phase images. From the phase images, we can know the defects. Likewise, pulse compression. So pulse compression is similar to radars. In the radar, what happens? One signal is transmitted and reflected signal is captured, and we will compare the transmitted signal and reflected signal. Reflected signal will be delayed when compared to the transmitted signal. So when you cross correlate it, we will get a peak at a position where exactly how much delay is there, we can know from the location of the peak. So that type of technique is used here. That is, at each pixel location, whatever we will take from the profile of a non-defective position, we will take it as a reference, and at all the pixel locations we will cross correlate it, and whatever say value you will get, we will replace at the same location, so that we will get a peak at the delay position. So based on the delays, we can know at what depth the defect is present. So that is this technique, pulse compression technique. Similarly, CZT phase is another technique. So in this method, what happens? First, we apply fast Fourier transform. After doing the fast Fourier transform, we will select a band, that is suitable band in the fast Fourier. After applying fast Fourier transform, that is where we think that defect may be lying. A suitable band of frequencies we will select, and we will zoom that band. We will zoom that portion. So so that we can, using this CZT method, we can identify defects lying very closely. So here, if you apply fast Fourier transform, due to the less frequency resolution, some defects lying at particular frequency point may be missed. So when you use CZT phase, defects lying very closely can be traced. That is the advantage. So here, just as an example, that is as an experimentation that is conducted in a laboratory. So here, this setup is used, for example. So here, this is the material. Particularly, so here this is the material that is placed intentionally. So this type of this material is used. Here some holes are drilled with different depths, and this is placed here. That is, this is the back view. On the front side, we will project these lamps. These are halogen lamps. These are halogen lamps. From this, we will control the stimulation. Which type of stimulation we want from the computer, we will control it. We will project onto this. And here is a IR camera. So this IR camera will capture the response. Okay, so this is the experimentation method. So these are the two materials are used. One is black color material is fiber type of material, carbon fiber type of material, and another one is mild steel material. Mild steel material is used here. So this is after doing this technique, after capturing the sequence of images, pre-processing, after doing the post-processing, we will get various frames. After that, within the frame, we will search for a frame where good contrast is available. So using this, we will.
Yeah, wrap up, sir.
Okay.
Yeah.
Okay, so here, so these are the methods wherever the different results we can see here. So using different method processing methods, whatever images we got. So using that, if CZT phase images method, post processing method is able to give all the defects, locate all the defects using that thermal images. This is for mild steel sample, and after that. Capturing the images, we can do even segmentation. Automatically, we can do segmentation methods can be applied to extract the locations of the images, and finally clear picture of the defects if you want to know. So that can be assisted. And these are the advantages, that is of this IR thermography: fast inspection rate, non-contact methods, easy to interpret, and has wide application. Whereas some difficulties are there because illumination cannot be done uniformly throughout the object. That is, if the object size is large, that is the problem. Cost of the equipment. IR camera is very costly. So as we want more good resolution, IR camera rate also increases. So emissivity, radiation problems are there. So these are the problems here. So coming to future scope and further research, these are here certain materials like metals will respond very quickly. So we require fast rate cameras, high frame rate cameras that are very complex. So due to that, various methods, signal processing methods can be used to increase that frame rate. And machine learning algorithms also can be used to localize segmentation purpose and for that in future. So that's what the future scope is. So this is what I wanted to say. These are the references I have taken. Okay. So thank you, sir, for this. So
Thank you, sir.
Yeah.
I request the participants if you have any doubt. Sir, it's a very good topic. There are several applications are available, especially railway track checking,
Yes.
and bridges and
Yes.
apartments, many stores.
It is a multidisciplinary also, sir. It is a multidisciplinary.
That's why. I will ask you one question, sir.
Yeah.
Palm a theme, and why can't we establish a setup?
Yeah, we can establish
That's
that. Yeah.
yeah.
Little bit. It is a little bit costly, sir. Camera is costly, sir.
Okay,
Totally.
that
Actually.
we'll think about it.
Yeah, yeah.
And a prototype with the
Yes,
help
yes,
of
yes,
lower end we can establish, and
yes, yes, yes,
once everything is okay, then we can go for high
yes,
end
yes.
equipment, and
Sure,
where we
sure,
can
sir.
have a chances of
Yeah, yeah. Scope is there, sir.
so
Scope is there,
yeah.
and less research is there in this area. We can. There is no
Mm.
much crowding is not there. Very
So not
few
only you, the
labs.
many of the faculty
Yeah.
they can think about it. Why? Because
Mm.
there are several concepts are involved here. The
Yes.
segmentation
Mm.
and frequency conversions, and
Yes, yes.
so
Signal
multiple
processing.
people, even from the civil
Filter.
domain, they can involve here.
Yeah,
The material.
filtering is there. Yes, yes, sir. Filtering
Yeah.
part is there. Signal processing, image
Yes.
processing. All
Yeah.
many things are involved here actually. So
Yeah. So I request you think about it, and
yeah, 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 sir.
so if you
Uh,
write it, so means the proposal and form a team,
yeah,
so
yes,
then
sir.
it's
Sure.
good. You can
Yes,
establish.
yes, yes, sir. Yes, sir.
So this is my opinion. If you have
Yeah,
any the participants,
yeah.
sir, yeah, Kizar sir, please conclude.
Sir, sir. Okay, sir.
Conclude it.
I thanks, yes, sir. I thanks to today's resource persons, Mabu Pasha sir, for giving very nice lecture, and I thank all the participants also who stayed here and get the knowledge. Thank you, one and all.
Yeah.
So with this, we stop the session. We
Okay,
end the
thank you.
session for today.
Thank you, sir. Thank you, Director sir, also Mohan sir, who is also available. So thank you, sir. Thank you for attending, and thanks all of you for being patiently attending, listen to my lecture. Thank you, sir.